Hi everyone. My name is Iris Danauskis. I'm from South Technica and I'm the product manager for the Spectrum Compact product line. And this is my colleague here, Jonathan from United States, who's responsible for the sales of Spectrum Compact in United States. And today we will talk about the passive intermodulation, or in short, PIM.
Speaking of PIM, so density and traffic are creating scenarios that PIM is more likely to be present. What is PIM?
The definition of PIM is it's a passive intermodulation, or PIM short, is an interference that is resulting from nonlinear mixing of two or more frequencies in a passive circuit.
So passive circuit. What is a passive circuit?
Okay, so the passive circuit is discriminal metallic junction and corrosion rust that are there are just a couple of examples of what is the most common PIM sources. And so, do you know why would I care about it?
Yeah, so going off some real life examples we have, you can be broadcasting from one of your towers, creating PIM interference in your own, or even worse, another entity's frequency band. Ultimately, this is going to result in making the affected frequency block be less efficient, have less capacity, and is ultimately going to make your users experience dropped calls, slower speeds, a worst case, not even be able to use their phones. So that means you can't browse Instagram or send text messages or call your mom on Christmas. So how do I prevent or stop PIM from happening?
Okay, so ultimately what you would want to do is that you would design a cell site with the PIM in mind. So you would start from that bit. But as we see, it is not always possible actually in most cases. So the next best thing you can do is actually that once you have the site designed, so you would take appropriate measures to mitigate the PIM. So either it's internal or external PIM mitigation.
Wait, there's two different kinds of PIM?
Oh, yes. So when we're talking about PIM, so there's like the general division is that there's internal PIM is the in PIM that is originating inside the radio system. So in simple words, saying that everything that is from the radio in the connection to the antenna and in the antenna itself. And the external PIN is something that is originating outside of the antenna, so maybe somewhere near the site, some objects that are in the way, sort of in the way of the main beam of the site. So, but knowing all that, how would you correct that?
Well, I mean, knowing these details is actually one of the most important aspects of designing a site correctly or correcting the issue as a whole. If your site has PIM. So as far as internal PIM is concerned, you would need to establish where the problem or problems exist within the system. At the moment, there are several companies that offer products that can help you do this. We're not one of them, unfortunately, but using those products, once you've established where the problem or problems exist, you can simply correct them. It could be a bad connector, you need to replace it. It could be a dirty connector, you need to clean it. It could be you didn't torque the connector down to the specification required. Simple things like that will be what makes an internal PIM a headache for the mobile operator or the person installing the site. External PIM is similar, but it would require you to identify the issue the same way with different equipment, obviously. Finding the culprits is a completely different process. So you would need to have those two signals being broadcast, the ones that create those passive circuits, while using a spectrum analyzer, near field probe, and then also make sure you're using a filter as well. And then it's as simple as tuning into the frequency that is the culprit, so the IM3 that exists, and then you literally find the physical location. Just think like a metal detector.
Yeah. Oh. And okay, so I see. So here we have a right exact equipment, so that we would be using for locating external PIMs. So what we have is the Spectrum Compact Spectrum Analyzer. So what then we have a RF filter that filters out the strong signal from coming from the base station, and then you have a probe near field probe for which you would use to locate a exact location or exact object that is generating this passive intermodulation near the cell site.
And with the help of that one customer we actually added features to this that help you. So this is a swept tune analog device, so obviously it's not as quick as an FFT device, but we added a zero span mode, we added a theremin tone. Yeah. So basically you can use this with headphones or hook up a speaker and move it around, and you hear the proximity based on the pitch, right?
Exactly. Yeah.
Okay.
Yeah. And this is, I understand. So this is also how the customer is using that in actually in field.
Yeah. Yeah. It seems to be working rather well too.
So we will have a demonstration about that. So today we're here testing a PIM finding solution with Spectrum Compact, and to generate this PIM we are using two radios connected to each connected to its own antenna, and it is they are transmitting on a frequency on very different frequencies in order to have the intermodulated product created in the elements across the room. And here, so they are now connected to the radios connected to the antennas, and they are set to work in different frequencies. And here on the other side of the room from the transmitters, we have three various elements can be found typically on the masts or on the rooftops near the communication towers, which in our case we will be using as a sort of PIM sources, which will be generating for which we will be doing the testing on how much of the PIM they are generating. So here we have connected the near field probe with the RF filter. This is the passband filter for the 1700 megahertz RX band for mobile frequencies. And this filter allows us to filter out the strong high-level signals from the transmitters, but it passes through the signal from the PIM source, which is which then falls in this frequency range. And here, of course, we have the Spectrum Compact, and now we need to configure it for us to make an efficient measurements on the PIM. So now we turn on the device, so it's like a couple of seconds and it's ready to do the measurements. So first of all, I want to set up the audio accessories I have with me, and this will allow me to not only see the signal level changes, but this will also give me an indication, the audio indication on the signal. Changes instantly. Here we then go to the zero span menu. Here I input the IM3 frequency
for which well I will be doing the measurements. So this is the IM3 measure frequency is the combination of two transmitter frequencies. And yeah, and this and this additional level menu allows me to set up the squelch line and the maximum line. So this is sort of to give me an indication of how what are the limit lines for the audio I want to hear. So the audio will start when the signal is higher than the red line, and it will reach its maximum pitch at the green line. Okay, so before doing the measurements, I will set on the LNA, which is built-in low noise amplifier, because typically the PIM signals from PIM source are rather low level, so this will allow me to do the measurements. So okay. So yeah, so here we have some indications that we have some PIM source. So you can see that this sort of gives some level of we are getting some PIM readings, but here it is clear that those elements, so those are a couple of rusty elements. They give a significant levels of PIM in that frequency, which we have both indications. Once we touch with the probe to the device, it is vibrating, so it gives an additional peaks from that. So if we go further, for example, we test it here. So we do have some PIM readings on this material as well. Since we touch this one, so this is very, very apparent that here the PIM, the intermodulation products from those two carrier frequencies here are generating very intense.
Thank you for joining for today's webinar, and we are now streaming live for the Q&A session, and joining online is also Jonathan, and we have some questions already from our viewers, so we will go forward with them. So we are going to you, Jonathan, now.
Hey, thanks for joining us, everybody. And Ivis, by the way, thank you for the lab demonstration. That was actually really cool, the way that you were able to replicate that scenario in the lab there. Something that I want to touch on as far as the question goes, that was highlighted out or stuck out to me, was, Ivis, why is the use of a filter so important when PIM hunting?
Okay, yeah, so the filters are important because the filters what they do is they filter out the strong signal from the transmitter. So in the case with the PIM hunting, this would be most probably the strong signal from the mobile base station. And that is necessary because otherwise this very strong signal would overpower the receiver on the spectrum analyzer side, and it will desensitize the receiver. And this means that since we are working, when we are looking for the PIM sources, we usually work in relatively low signal levels comparing to the base station power levels. And this means that if we wouldn't be using a filter, we won't be able to see or detect those PIM signals which are relatively low level. Yeah, and that's and going to the next question is maybe for you, Jonathan. Where should I look for external PIM sources?
So that is kind of a tricky situation. That really depends on what your site looks like, what kind of site it is, but you have the opportunity to kind of address the low-hanging fruit when you check out your site, looking for things that you can possibly do. They refer to it as hygiene. This is where you're swapping out the rusty metal brackets and things like that for plastic ones or whatever the case may be. And then for the tough stuff, finding the very specific, could say more difficult to find PIM sources, that's where you would, let's say you're on a rooftop, you would actually take that setup that you had in the kit that you did in the lab, and you would search for the source, basically. So it could be something like flashing on the parapet wall of a roof. It could be something that you can't even see. And then it could also be something that's near field, which is what you're using the near field probe for. It could also be something far field as well. So something that you're not in control of in the environment past your, past your site. So it's, I know that was kind of a convoluted answer, but it could be anywhere, honestly, anywhere on the site and anywhere surrounding where the signal is touching. Looks like another question. We'll pass it to you, Ivis. Is what is the main cause of external PIM?
Okay, yeah. So I think this is something that you already touched on in previous question, and those from what we heard from our customers, and it of course it very much depends on the site, cell site in particular. And if we're talking, about the rooftops, so those can be some rusty metal parts on the roof, parts of the roof itself, or it can be railings on rooftops, or it can even be some sort of loose metal parts, some parts used for attaching cables, for example, to the poles, and which are basically somewhere near to the base station antennas, so they can be located like in couple even we're talking about couple of meters from the antenna, and then so those could be some of those examples which can cause a PIM. Yes, so. And Jonathan, so maybe you can also comment on the next question. Is about that. I would like to know more about effective ways to tackle PIM on congested rooftops, multi-tenant telco sites, high-density locations. What can you comment on that?
So this goes back to what we initially talked about in the video, where probably the most effective way that you and your team can tackle PIM on congested rooftops or multi-tenant sites, high-density locations, just like the question illustrates, is making sure that you and your team are educated on what PIM is, what the standards are of your particular client, which could be the mobile operator typically, who would be hiring you to help solve these problems. And then it's really just kind of making sure that you're not going around and chasing ghosts. And what I mean by that is it's possible to have something that isn't even a problem on the site. This is where that far field stuff comes into play, where you could make an adjustment to the direction the antenna is, or how far away the antenna is from the roof, or from the edge of the roof rather. So it's really just being educated and using that education, taking it seriously, and really kind of falling back on that as a backbone. It can be challenging sometimes on these sites to really stay focused on what you know, because you're rushed. You want to get it done. Typically, sometimes you only have like 1 to 3 days to knock this out, depending on what your standards are and expectations are. So, and that's lastly, that's the other thing I'd stick to is follow the MOP or method of procedure that your client gives you to a T, because that's there to help enable you to be able to kind of have that system in place to fall back on when you're searching for things. And then I know I said lastly, but one more thing, don't be afraid to ask questions either. Everybody in this industry knows how much of a challenge this is. It's okay if you don't know something specifically, and this is where reaching out to the cell tech or the regional manager, whoever's in charge and has the information. Don't withhold information. Don't lie about what you know, and ask questions. That's the only way we're really going to effectively get through this. And yeah, that's how I do it.
And so we have another question. I will also pass to you. It's what does the audio feature of the Spectrum Compact accomplish? So I know that this is something that we worked a lot on, and it was like very interesting feature that we had to develop.
So the audio feature, the specific customer that we set this up for, they wanted a way to have a device that wasn't large. It was a very simple, was very rugged as well, but also they wanted the ability for the person using it to not rely on looking at the screen to find where the actual PIM source is. So the way we have it set up is, when we talked about this in the video, is you have a sense of proximity with the tone. It sounds very much like a theremin. So as you get closer, the pitch increases, and this is all dependent on your settings. Keep in mind, you've got the squelch line and then the max line. So within that window, you will have the pitch increase, decrease, depending on how far away you are from the PIM source. And you don't even have to look at the screen to verify that. You can hear it in your ear, or like with Heather, you can actually plug it up to a speaker if you wanted to. So it's just a simple way to be able to kind of hit the ground running when you get to a site. You don't have to worry about setting up. For the most part, you don't have to worry about something warming up. You can get right to work as soon as you hop on the site. You don't even have to be an expert in RF to use it either. So, and then looks like the last question on this slide specifically is for, we'll pass this to you, Ivis. How do I know if I have a PIM problem?
Yeah, well, that's a good question. Well, you know it if you would notice it if you have a PIM problem. But so far, it's clear that the PIM is causing a receiver to be to desensitize, meaning that you would have a larger noise going into the receiver than you would expect normally. And this means that even if there is a PIM, but if it is on a very low level, meaning that the PIM level is lower than the noise typical noise level, it basically means that you are not noticing it on your receiver, and yeah, basically at that moment you can consider that you don't have a PIM problem. But if the PIM is a problem for the cell side, it means that the receiver side will be with an increased noise, and then it of course up to the mobile operator to do procedures of estimating what is the source of this noise. Is it some active transmitter which is misusing the frequencies, for example, or it's some interference that is going in from also either from external source. It can be also, then it is, if it looks like a PIM, so then of course there's procedures where you have to understand whether it's an internal PIM or external PIM. So those procedures, of course, they depend very much on the operator internal procedures in general. Yeah. Okay, I'm just waiting if there are. Okay. Oh, okay. So this is, we have a question here. Is that what makes the RUS to act as a frequencies mixer and PIM generator? Yeah, so this, Jonathan, if you feel like you have a good answer, you can comment here. I would say in this case, so this means that at the moment when the metal part is getting rusted, so it sort of starts to work as a I forgot the name. It's not anymore working just as a conductor, but it sort of it makes those frequencies to mix in together. And sort of this creates this non-linearity in this element, and it basically becomes as a passive circuit, and this is what creates this PIM, because from the name of the PIM, the passive intermodulation, this means that it is the combination of those frequencies. They are happening in the passive element, which is like it's not powered with anything.
Yeah, and I don't. Just so you, you nailed it. I don't have anything to comment on that. So you hit the nail right on the head there.
Yeah. Okay, so it seems that we have no more questions for today. Thank you for joining for today's webinar. We hope to see you on the next ones, and you have a good day there.